Now that we have understood the listing of the data and how to construct a frequency table, now comes the concept of how this data can be represented graphically. This session is about graphical representation of data. It is very important to represent the data through graph because the whole concept of statistics is itself about analyzing the data in the real life situations. Therefore, the real life situation demands more of pictorial representation or graphical representation of the collected data. There are three types of graphical representations which we use most frequently in the branch of statistics. The three graphical representations which we are going to deal in the syllabus are bar graphs, histograms, and this. The three graphical representations of the data collected can be analyzed through the bar graph or through the histogram or through the frequency polygon. Let's see each of them classified individually. Now let's see the first type of graphical representation of the data, that is bar graph. Bar graph of the session. So let's see how a bar graph is understood in statistical means. For example, I take the graph of math marks and number of students. So for example, I have the marks on x-axis and number of students on this, where they are listed through this graph. It generally has bars in this form, and the bars make us understand that the number of students who got marks between 40 and 50 are 20. So here I can convert this into a frequency table by using the bar graph. So before understanding the bar graph, let's try to convert this bar graph into a frequency table. So in this case, I have math marks and the frequency, which is number of students who got those math marks. Now I have this classified into 40 to 50, 50 to 60, I have the graph which shows between 40 to 50 and 60 to 70, and then 80 to 90 and 100 to 110. So for example, this is an example graph which I understand through the frequency table. So the number of students who got marks between 40 and 50 is an elevated bar which reaches up to the value 20. That means there are 20 students who got marks between 40 to 50. The 60 to 70 gets elevated up to 5. So I see the tip of the bar touching the value on y-axis, which gives me the number of students being 5. Next, 80 to 90 touches at 30. I understand this touching at 30. So there are 30 students who got between 80 and 90. And 100 to 110, I see this touching up to 15. So I have 15 students who got the marks between 100 and 110. So class interval and frequency is understood through the bar graph. The size of the bar gives me the class interval, and the tip of the bar touching the y-axis gives me the number of students. Is how we understand the bar graph helping me in deriving a construction of frequency table. Bar graph helps me in analyzing the data in graphical representation. Now that we have discussed about the first graphical representation, let's get into histograms, which is the second graphical representation. Bar graphs followed with histograms. Now imagine I take the example of a teacher trying to collect, the physical education teacher trying to collect the students' weights, and that purely comes in with histogram. Let's see how a histogram helps me in classifying the data. For example, I have weights of students in kilogram, and my y-axis is number of students. Then let's say the graph which gives me out here. In a class of 25 students, I want to take the weights of students in kilograms on the x-axis in such a manner that I start from 35, 45, 85. Say for example, this is my weights in kilograms and this is number of students. Let's try to convert this into a frequency table and understand how an histogram helps me in analyzing the frequency table and the data itself. So when I take this into the tabular form, I clearly see weights in kilograms and number of students falling in that range. I clearly see that 35 to 45 kg range gives me 5 students who lie in this range. So the students who weigh between 35 to 45, there are 5 students lying between that weight. 45 to 55, there are 15 students who lie in this range. 55 to 65, there are 10 students who lie in this range. Then 65 to 75, they lie in the range of 25. and 75 to 85, there are only 2 students. If I approximately take here, I see that 75 to 85, the frequency is 2. So the given histogram, when converted to the frequency table, I clearly understand that the students who have their weights in group data have their frequency picked from the tip of the bar and then with the value on the y-axis. This is 5, this is 10, this is 15, this is 25. That's how I get the frequency, which in turn makes me understand in real life situation that there are 5 students who lie between 35 to 45 kgs. There are 15 students who lie between 45 to 55 kgs, etc. Histogram connected with a frequency table. It is very important to note when we take the first graphical representation, that is the bar graph, connected with the second representation, histogram. What is the difference between a bar graph and a histogram? Let's see the note. Histogram has all the bars connected continuously without any gaps, unlike the bar graphs. It's very important to note that in bar graphs we had gaps in between, but when we take the histogram, there is no gap, but they are continuously developed until the last. So the one major difference is that histogram has all the bars connected continuously without any gaps, unlike the bar graphs. Is how we differentiate between a bar graph and a histogram.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.